Well, thank you very much for that kind introduction. Is this mic working at the back? Hear me? It's a difficult position for me. I represent Google, as you know, a company very interested in making information as widely available as we possibly can. We recognize the fact that when crises happen, when disasters occur, information plays a very huge part in mitigating the results of that. Although our view is probably mostly in that mitigation management piece, not so much in the management of risk and trying to understand what that risk is. So rather than talk specifically about risk management, I want to talk a little bit about how the internet, the cloud, as it's now called in some places, is developing and how some of those developments may aid risk management, may aid disaster management as we move forward. So it's a very broad picture without too much detail. If you want to drill down into the detail, please feel free to ask me questions later on or over lunch, and I'll be happy to drill in. So as you know, Google is all about finding information. And from my point of view, fortunately, a lot of the information that we are often looking for is about a place. In many cases, the searches that happen on google.com or google.co.uk or on your mobile phones are about a location. Somewhere in the order between 30 and 40% of all searches are actually about locations, about places. And that's obvious when you think about it, because everything that happens somewhere. And that somewhere is a mechanism that we can use to help order, help make the information that is potentially more relevant available to people. And that's really what Google does. Google looks at all the information on the web, all the information that's published, indeed helps publish information on the web. And then our main task is to say, okay, for an individual user, this is a piece of information that is relevant to them at that particular point in time, trying to carry out the particular task they're looking to do. So everything that we do is about that process. Now, as I said, often when we're dealing with disaster management and the crisis team at Google is up and running, it is about trying to find the relevant information amongst all of those billions of pages of content on the web that is going to be useful to people. So really, how do we deal with disaster management in this networked age, in this age where there is abundant information? That abundancy is the real problem. If you'd have asked me when I was a child growing up in the 1970s in the UK, at some point, in 2010, you're going to be standing up in Washington, D.C., giving a presentation to an audience about disaster management and risk management. What sort of topics will you be thinking about? Well, as a child, I would have thought it had been something along these lines, where we would be developing these huge craft that we could send off to a disaster, and we would save everyone at the very last minute. Everything would work out. Now, of course, Thunderbirds, science fiction, international rescue, it's the stuff of childhood dreams. None of this could ever come true. But in some ways, the technology that we actually have available to us today through the web, through the technology that we carry around with us, in many ways is far more advanced, far more powerful than what the science fiction writers of the 1960s and 70s came up with. The tools that we have today are just amazing. They are magic compared to what was available only 10 or 15 years ago. But the tools themselves are only part of the solution in managing risk, in managing the impact of disasters. Because more than anything else, and we mustn't forget this, disasters are about people. So when we've developed tools in the past around disasters and for crisis management, actually those tools that perhaps have had the biggest impact, that have been most valuable and have been most powerful, are in some cases the simplest ones. We developed for the Haiti earthquake and then the Chile earthquake that followed on this very simple tool that literally took engineers a few hours to develop. But it allowed people who were displaced, who were looking for friends, family, relatives in the area affected by the disaster, just to register the details. I am looking for X, or I am X and I am safe. And a very simple tool allowed people to fill in those details and then for the information to be searched online. So despite all the technology, the thing that was most powerful was something that was focused on people and on communicating, giving people the mechanism to talk to each other. And that works across all levels, whether you're people affected by a natural disaster or whether you are agencies and NGOs wanting to help those people themselves affected. Communication and using the cloud, the web, to communicate more effectively is something that we're beginning to come to see as perhaps the most valuable thing that we could do, is to help develop these tools. Nevertheless, though, we can see a kind of evolution in terms of how we've used the web in terms of the functionality and the tools that are there. Now, this is obviously from a geospatial perspective. You know, I'm most interested in geospatial data, mapping, imagery, and so on. But there are some bigger trends here that I think you might see as well. We start off, initially, the web, the cloud, is about making information more accessible. By publishing information on the web, more people can get access to it more easily. As a byproduct of that, perhaps, but as a very strong connection to that, making information more accessible, we can also see the web as a tool for creating communities. Communities that are interested in particular aspects. We saw that most recently in the Haiti example, where many, many people around the world formed a community to help in any way they thought they could do. That's probably where we're at now. The next step in that evolution is to what we call grid computing or cloud computing, where we use all of the computers and the services that are attached to the internet in a kind of collaborative or collective way, solving problems that were previously unsolvable from a computing point of view. When only 1 million computers will solve a problem, well, now we have 1 million computers available to us. So let's look at those steps in the evolution separately. Let's look first of all at making information accessible. Geospatial data is just a click away, and the thing that has made the biggest difference here is this idea of creating platforms exposed via APIs, application programming interfaces. As a GIS professional, for 20 years of my professional life, I tried to sell GIS technology to people, and it was a hard task, because what's represented here on this slide was just too difficult to do. It was very difficult to go and acquire the base geospatial data that you needed to use. You had to go and visit many different organizations, some commercial, some governmental, to try and find the data that you needed. Then you would have to use quite arcane and sophisticated software to try and manipulate and manage that. And then it was very difficult to share that information, sending out CDs, printing out maps in map tubes and so on. Today, a lot of that complexity is completely hidden from the end user. It sits behind that application programming interface. All the data is there, easily accessible to you. The means of distribution, i.e. getting potentially petabytes of information across the internet onto a mobile device in a field in the middle of Africa, is there today, real. All exposed via free and open APIs that are accessible to anyone. This has changed what we do in the mapping industry and is changing many other areas of information. From a disaster management point of view, an obvious example of this was happened in Australia last year with the bushfires, where all of that basic underlying infrastructure ends up being exposed as a pin map, where people are, and this is literally people are contributing information. Those information is being rolled up to give people a real-time view of where bushfires are. So by making these platforms and APIs available, we have made it possible for individuals to contribute, the bottom-up approach to become as prevalent, if potentially not more prevalent, than the traditional top-down approach. But the biggest impact of this platform and making information available via APIs has been in terms of the accessibility to imagery. This is, you know, some of now probably the most well-known imagery that you'll find on the internet from a geospatial point of view. These are some of the images that Google ourselves we acquired over Haiti about 4 days after the earthquake. This is very high resolution imagery, sub-meter, in this case it's probably about 15 centimeter resolution imagery. That means you can actually see individuals, you can see people. You can see people on the streets, in the parks, in tented communities. That has a huge emotional impact on people. People that view that image have an immediate connection to it because, one, they see people there, but they also are looking at it in a tool that they have become familiar with. There are 500 million people around the planet have downloaded Google Earth and have used it. That's about a third of the users on the internet. That's a lot of people with an awareness of what imagery means. Now, from our perspective, we have learned through the conference today and through our knowledge that this kind of vertical imagery has a huge value, and certainly when it's made available as quickly as it was after Haiti is incredibly beneficial. But there are also other imagery types that are becoming increasingly available as well. We've heard on a couple of occasions over the past 2 days about this oblique photography. This is coming from, in this case, pictometry. Here you can see much more detailed information, particularly from a damage perspective, that you might not necessarily be able to see with vertical imagery acquired from aerial photography or satellite imagery. Now this is more difficult to collect because you need to fly aircraft at a lower altitude and it takes more flight lines to capture. But there is a huge benefit to this in that the equipment used to capture this sort of imagery is pretty much standard. Now you can use digital SLRs that I could go a couple of blocks away in the camera shop and buy off the shelf to use to capture this sort of imagery. And people are beginning to look at how can we use this off-the-shelf equipment to very much more quickly capture this sort of imagery. To the extent, only last week I was talking to some people in Ireland who had built a camera mount on the bottom of a radio-controlled helicopter that would allow you, believe it or not, to go and capture a few square kilometers of this oblique imagery very, very quickly, within an hour, with an equipment cost in tens of thousands of dollars. Okay, now that's kind of an edge case. But you can see a pattern emerging here where once upon a time we might have had to buy a $2 or $3 million metric camera. Now I can capture imagery using digital SLRs and do the processing in the cloud. This awareness and the availability of imagery is also being used now to communicate much more clearly issues and to be able to potentially put forward across points of view in a more powerful way. Some of you may have seen this website that was put up by an engineer that works at Google called Paul Rademacher. And it's a very simple application, a very simple website that monitors the size of the Deepwater Horizon oil spill, and it's taking a feed from some data that's being acquired by NOAA. Now, the problem with understanding the impact of this event is that, well, it's happening off the coast of Louisiana and Mississippi, the Gulf Coast. Very few people have a great geographical knowledge of that area. So what Paul did, and this is a very clever technique, was to take the extent at any particular point in time and allow you to displace that image, that extent of the slick, and put it somewhere else that you might know more about. So if you now see that overlaid over Washington, where we are today, you can see the huge extent of that slick. And it works well posting over London or Paris or wherever else you might be interested in. It's using this technology now as a communication tool to put across a message. Now, we've had a lot of talk over the conference about Haiti and the impact that Haiti has shown in terms of suddenly a huge community being interested, imagery being made very accessible. We shouldn't necessarily assume, though, that what happened around Haiti will ever happen again in the same way. We have to remember that here was a case where the imagery was released incredibly quickly. Imagery was released even before the UN Charter had been enacted. And there was huge media interest in Haiti. It was 2 hours flying time from the United States, so it's easy to get aircraft and crew down there. It's also very easy to get the media down there. And it's particularly important if you think about the fact that the earthquake happened in a time zone that was the same as the east coast of the United States, so it could appear live on the major news channels. Not all disasters will be as media friendly, I'm afraid. We've all seen how powerful having data accessible in this way is. We need to make sure that availability of imagery in the same way, with the same speed, is something that is sustainable, is something that happens every time now, from now on. So, communities. Haiti was that great example where suddenly there were literally tens of thousands of people wanting to help, contribute, use geospatial tools in whichever way they could. And there is wisdom in the crowds, as we've heard over the conference. Or perhaps, as I would say it, wisdom in the cloud. And you must forgive me for my outrageous Star Wars fandom on this one, but it was just too good an opportunity to miss. There is wisdom in the cloud, there is, but search for it you need, in true Yoda speak. Did anyone see Yoda in that, or was it just me? You see it now? Yeah. So, any excuse to put a good photograph in. Now, the reason for that photograph, there is an underlying message here. In that the cloud, the internet, having connectivity does allow us to do things with a dispersed and diffused group of individuals that are interested that were just not possible before. For us, our real insight to this came with another cloud. This is Cyclone Nargis in 2008 that hit Burma, as you'll be aware. Huge impact, as many of the cyclones in this region have. Our problem was when we came to think, well, how can we help, how can we make information more accessible, was the quality of mapping that we had at that particular point in time. Got to remember, when we start off with Google Maps, we don't wait, obviously, until we've got the whole world. We build it up incrementally. In some places, for various reasons, there was no data availability. Now, it just happened at the time that Nargis happened, we were developing a tool to allow the communities to start to create mapping themselves. We recognized that this was going to be the only way that we'd be able to map large sections of the world where there was no commercial or governmental source. So we deployed that tool with some other people working at Google and said, okay, guys, here's the issue. Use satellite imagery, whatever local knowledge you have, what can we do? And within 4 days, we had a map of Burma that was then accessible and made available to people to use. Now, obviously, we are but amateurs compared to OpenStreetMap at doing this. And OpenStreetMap has been one of those real epoch-defining movements on the web. It's had a huge impact. And of course, they did fantastic things around the Haiti earthquake and produced, as people I think have said during the conference, perhaps one of the most detailed digital maps of anywhere in the world now is Port-au-Prince. There's been so much time and effort and energy have gone into that. So it's a fantastic piece of work. But we have to recognize that there are also limitations with this crowdsourcing, cloud sourcing of data. In that sometimes communities need a bit more structure, they need a bit more direction. The other map you see there is of northern Haiti, and it's much less detailed than Port-au-Prince. It's not that it was any less impacted by the earthquake, marginally less. There were still major impacts there. The reason that it was less mapped was partially there was less imagery available for the northern part of Haiti, but also communities, I think, when it comes to mapping, operate a bit like 4-year-olds playing football, soccer. If you've ever watched 4-year-olds playing football, they always follow the ball. So they go running off in whichever direction the ball is, and then you kick the ball somewhere else, and they all run off in that direction. Crowds, when it comes to creating data, operate a bit like 4-year-olds playing football. Sometimes you need a bit of direction to say, okay guys, goalkeeper, you need to stand here between these two posts and wait for someone to kick the ball in your direction. Okay, an obvious example though, but I think we can forgive the fact that, okay, these developments are basically new. These communities are being created, and those communities over time will develop knowledge of how better to interface with government agencies and NGOs and so on. They will form the structures that we need. And those structures will help us in terms of developing the quality and the trust in that data that we need. And there will be different approaches taken. For example, when we create data using the community, we have a moderation process that's slightly different to the process that OpenStreetMap uses. And you will see different processes, different ways developing over time. This will, without question, be a hugely valuable source of data. But it's learning, it's growing up, it's still at those toddler stages. But the main point around this, though, is this one. We need the base data before the disasters happen. It's great that the community gets involved following something like Haiti or the earthquake in Panama. But actually we need to be there beforehand, making sure those databases are in place. There's also an interesting element when it comes to crowdsourcing, the difference between explicit sourcing of information by using the community and implicit. Now, everything that we've done so far really is about explicit data capture. And there's a long history beyond just mapping. The idea of the mechanical Turk that you might have heard of. This really came to prominence when Steve Fossett, the famous aviator, had a plane crash out in the west of the United States. Huge territory, very small aeroplane, very difficult to find the crash site. So this website that was created using Amazon's cloud storage system, whereby as an individual you could log into this website and you'd be given a little square of area to look at and to do a visual interpretation. If you could see the airplane there, click one button. If you couldn't, click a different button and you get another square of data to look at. We've kind of extended that idea to building three-dimensional models. This is our building maker that uses that same process. We can automate so far, but sometimes you need an individual, a human, to help you finish the model. When the Allies invaded D-Day, they used things called Bagot maps. And Bagot maps had been created by looking at tourist photographs of the Normandy coast that had been collected by tourists traveling to France in the 1930s. We are, in effect, creating Bagot maps now by looking at the widespread availability of images that are geocoded and available at sites like Flickr and Panoramio. These are examples in Panama City, and there's very extensive coverage almost anywhere that you might want to visit. And that will give you a sense of what is the place like today in terms of being able to do risk analysis. Those are both examples of explicit crowdsourcing of data. Here's an example of implicit. This is a map of urban areas that a company called Skyhook have created just by sensing where mobile phones are. And if you think about it, where mobile phones are basically is a model, a reflection of where people are. And even in Africa, where there is a relatively small but increasing mobile phone distribution, this is a very valid source of creating data sets of urban areas. When you get down into those urban areas, you can create data sets like this. This is a road map of London created by just tracing where Google engineers were moving about. And this is literally, over a few months, you can build a street map of any particular city by tracking people's mobile phones. Okay, my final few slides, when 100 computers is not enough. Looking at grid computing. This is a website, it's an experiment, something we're working on called the Earth Engine. And this is trying to deploy all of those. Unfortunately, it's a company secret exactly how many computers Google has, but it's more than 100. It's about taking all of those computers and saying, can we use those to solve really big computational problems? In this case, can we do some basic image processing? Here, doing a supervised classification for deforestation. But taking all of those computers, something that might take a few hours processing normally, we can do in a few seconds. Final points then. We all have in our hands the world's most powerful computer. Not this mobile phone in particular, but any mobile phone that can connect to the internet can do things that were previously magical. The example here is Google Goggles. What's happening here is I can take a picture of any building pretty much anywhere in the world using my phone. The picture is uploaded to the cloud. Image recognition takes place in the cloud, and I get back a page that says, you've just taken a photograph of this particular building. and here's some information about it. This works now. I could demonstrate it to you just by going outside and taking a picture. Anybody in the room speak Albanian? Phew, I'll get away with this one then. Imagine you're in Albania and this boy comes up to you and says that. I won't try and pronounce it, although we are working on that technology in the phones that will do the voice, but he says that to you. Don't know what it means. Okay, it's not a particularly good example. Actually, what he is asking is, what is this understanding risk conference all about then? So, how am I going to respond to him? Well, I take my very nicely produced, very expertly produced brochure, very good, and I get my phone and I take a picture of what I think is the most appropriate section of the brochure to be able to explain in Albanian what this conference is all about. I take that picture, I then say I want that text, which you are now sending to the cloud and doing a image to text conversion. I want that converted to Albanian, please. And you get your result back in Albanian that you can show the boy and say, this is what the conference is all about. This is real technology. It's available today, now. And we are thinking of different ways that you could deploy this, obviously with a voice interface and so on. But these are kind of processes you could only do using that processing capability in the cloud. So my takeaways for you. Information is far more accessible today than it has ever been, but it still remains patchy, and we still need to keep the pressure on to whoever it might be to make that information more accessible, to make that information released. Communication is still a huge issue for us, and it's something that we think there's huge value in using some of these technologies to help solve. Mobile computing devices are going to have a massive impact, both in terms of allowing us to carry out these computing tasks wherever we might be, but also allowing citizens themselves to become sensors, to allow them to collect the information. The SMS message, "I'm trapped under the rubble," is the clarion call for these sorts of applications moving forward. Thank you for your time. I'm happy to answer questions later on.